Hi, my name is Muhammad Zuhari Fipi Matrix number DE100166. I will present to you about my PSM1, which is the hardware implementation of FIR filter for electrocardiogram ECG signal processing. Before we start, let's go to intro. Okay, here this is my content for my presentation, which is for the first one is project background, second one is problem statement, objective, scope and of works, methodology, preliminary result, and conclusion and future work. First of all, let's take a look for the project background. So here there has a three project background that I want to present to you, which is the first one is type of noise, second one is ECG monitoring, and last but not least ECG signal concept. So for the type of noise, baseline weather and motion artifacts from the patient's daily activities can cause incorrect diagnosis when utilizing mobile ECG. Meanwhile, for ECG monitoring, clinical monitoring and diagnosis of the heart conditions of the human heart, and last but not least is ECG signal concept. The electrical impulse will begin at the SH node, move to the AV node, then split into the right and left bundle branches. Okay, next, let's take a look for the problem statement. So here, the problem statement will also have a 3 point, which is the ECG signal noise, software based, and also the performance. So for the first one, the ECG signal noise, the voltage of the skin's second layer, known as the spectrum lucidium, is altered as the skin is stretched because this cause of a sort of noise known as the motion artifact. So here, my problem statement is for the first one is this to avoid the noise from the signal ECG. So for the second one is the software based. So FIR filter is used to the general purpose processor, which is the central processing unit or CPU. So as we know, when we want to avoid the noise from the ECG signal, I will use the FIR filter. But for my problem statement, the FIR filter is used the general purpose processor, as we know as the CPU or the central processing unit. So last but not least, in the performance, the code will run sequentially on the CPU, and this process will call serial processing because of the functionality of the processor is dependent on the internal hardware structure. That structure cannot be altered in any way to improve its performance. Okay, next, the objective. For the first one, to design the FIR filter using the window method for ECG signal processing. For the second one is to implement the purpose design on the FPGA. Last but not least is to verify and measure the performance of the purpose design running of a FPGA. For the PSM1, I just go through with the objective number 1, which is to design the FIR filter using window method in the MATLAB. So after that, I will show you how to design or how to filter the ECG noise from the original noise that implement using the FIR filter in the MATLAB. Okay, next, this is my scope of works, which is there has 6 total on this. So for the first one is the specific data will occur from the PhysioBank ATM database, and the second one is use the record test 45 seconds to filter the motion artifact contaminated ECG database. So here I will use this ECG database, which is the test 05_45 seconds. So for the third one is the using FIR filter that can minimize the ECG signal of the rate contraction of the heart. For the fourth one is the undesirable frequencies will remove using the Fourier transform mathematical tools. So here the Fourier transform will show you how we can identify the noise by regarding to the frequency domain. So for the fifth, which is the FIR filter, we design using Kaiser window, and last but not least is the produce the result without taking the longest time delay using the FPGA hardware board. So here, this is my methodology. There has 5 steps, which is show that in the block diagram. For the first one, the motion artifact noisy ECG signal will take from the PhysioNet database, and the second one is the plotting frequency spectrum FFT, which is I will use the MATLAB FFTX function. Third one is the FIR low pass filter with n equal to 20. Here I will need to use the command b is equal to FIR1 and omega n f type. For the fourth one is the Kaiser window method to cancel ECG noise. So here, to implement the Kaiser window in the MATLAB, I will use the Kaiser and beta function. Last but not least, I will filter and smooth the ECG signal using the filter B1 ECG signal command. So here, this is more for my PSM1, which is I only filter and smooth the ECG signal until I get the best one. So this is my preliminary result. For the first one, the data acquisition. So the data acquisition will take from the PhysioBank ATM, and I will use test 05_45 seconds, and the toolbox need to change to the export signal as .mat file, and also after that I will need to save .mat file in the MATLAB folder and utilizing the load function in the MATLAB. So this is the PhysioBank ATM will show in the figure. So I will change the toolbox to the export signal as .mat, and after I change it, it will pop up the figure below. So the test 0545sm.mat, so I need to download first, and then I will save into the MATLAB folder. Okay, next, after I load into the MATLAB folder, so I need to use the load function, which is as shown here. I load the 4 ECG signal from the Physionet bank. So for the first one, ECG1, ECG2, ECG3, and also ECG4. This is all original ECG signal in the Physio bank, so I need to filter it. So after that, I use the FFT so that I can analyze the power line interference. So I need to plotting the frequency spectrum that's shown in the figure here, and I will use the FFT ECG signal function in the MATLAB. So here, this is coding for the FFT frequency power noise. So as you can see here, I will use the L is equal to 4000 because in the requirement in the database, the ECG signal for this motion artifact is equal to 4000. I use the function of the FFT ECG signal. So as you can see here, it will pop up the frequency of noise FFT for the every single signal, which is the ECG1, ECG2, ECG3, and also ECG4. So here, there has power spike at the 60.125, 60.25, 60.375 at the frequency spectrum. So here, as I can conclude, the power spike or the power line interference that I need to remove, which is the equal to 60 Hz. After I identify the power spike or the power line of interference of the ECG signal, after that I will implement the FIR low pass filter, which is using the Kaiser window. So to use the Kaiser window, for the first one, I need to utilize the FIR function in the MATLAB to design the magnitude of response that's shown in the figure here. So this design will transfer the ECG signal into the normalized frequency range, and it also identifying the coefficient value from the FIR implementation. So after that, I will show you how the FIR1 will identify the coefficient value from the FIR implementation. So last but not least, in apply 30 step low pass filter, I will get the smooth response from the original signal. So here, this is the characteristic that I need to input in my coding in the MATLAB. So for the first one is the response type, which is I will use the low pass, and the design method is Kaiser window. Filter order is 20, sample frequency is 500 Hz that give in the original signal. Cut off frequency 20 Hz, and also the value of the beta, which is the beta is equal to 3. So the coding will prefer to the right side, which is the FIR filter, Kaiser window, low pass, and equal to 20. So here I will use the function of FIR1, which is here B is equal to FIR1 20 omega n low Kaiser 21 3. So here the FIR1 will pop up value of the coefficient from the FIR filter, so it will show in the workspace that I highlight that. So the workspace will show the B, the value n is equal to 1 times 21 double. So when I figure out the coefficient value, so we can see the transfer function will show like that. So there has 20 order in here, so I prefer to use the 20 tab to design the FIR filter with using the Kaiser window. And here, last but not least, after I implement the FIR filter using the Kaiser window, so I need to implement the FIR filter in the original signal so that it can smoothly filter the original signal and also can eliminate the 60 Hz noise from the frequency spectrum. So here, I will utilize the filter BAX function in the MATLAB, so it will moving average filter noisy data can remove. And here, this is recording for the last step, which is to filter the original signal, which is I will use the filter B1 ECG signal. So here B is the main of numerator, meanwhile for the 1 is the denominator. As we know, in the FIR filter it only has the numerator, but the denominator is equal to 1. So I decide to use value 1, which is to replace the value of the denominator. And here, this is the result for the ECG1, which is, as you can see here, in the frequency of noise FFT, there has 60 Hz power spike after we filter it with the Kaiser window, and it will reduce the noise start from 20 Hz because I set the 20 Hz before that. And you can see at the original signal there has a very much noise here, and after I filter it, it will show the smooth single signal for ECG1. So this is for the ECG2. It also use the same coding, and as you can see here, the power spike of the 60 Hz will also reduce from the frequency spectrum. The original for the signal ECG2, it will filter using the Kaiser window, And here same goes to the ECG 3, and last but not least for the ECG number 4. So here this is the conclusion and the future work. So for the conclusion, the FFT algorithm will be employed with a 20-tape low-pass FR filter and Kaiser window to locate power line interference. The noise damage ECG signal is routed via the FR filter, resulting in the smooth signal. So here we can see after I filter using the FR filter, Kaiser window low-pass filter, so you can see every single signal will show the result in the smooth signal. So for the future work, the FPGA application will be used in the work that will be done in the future to smooth that was wanted. So here I will proceed to the next semester, which is I will use the FPGA board to hide the performance of the filtering in the original signal.